Next, we have Sheeba and Nikhil from SAP Labs, who'd be talking about iScooper based automatic emergency patch testing solutions. Over to you.
Thanks, Samiksha. Hello, everyone. A very good afternoon to all of you from my side. I'm Sheeba Bazaz, and I work as a product owner in SAP Labs, SAP S/4HANA Test Engineering team. And with me, I have my colleague.
Hello everyone, I am Nikhil Relan. I have 9 years of experience and I'm working in SAP Labs as a senior software developer.
Yeah, thanks, Nikhil. So I'll be just sharing my screen. Give me a second. Okay. So, colleagues, we will be presenting today the topic of iScoper-based automatic emergency patch testing solution. So, I'll just quickly take you through the agenda. We will be covering the problem statement, what was the motivation for this innovation, the solution overview, and the little bit logic details. We'll be also providing a real-time demo, and finally, we'll be wrapping up the session with business benefits. And we ensure you that by end of this session, you'll get to know the secret recipe behind having a successful emergency patch deployment with minimal regression tests. So let's get started then. So as we all know, emergency patches are intended to solve business critical customer issues, which are to be pre-delivered into the customer systems. So in order to ensure that there is business continuity and no regression impact, a complete regression testing follows post-deployment of an emergency patch in the system. So, in for SAP S/4HANA applications, we also do a complete regression test with full scope. And however, the scope remains static. By static, I mean we don't have any scientific method in place to determine which are the regression test automates that correspond to the changes contained within the emergency patch. So this is one of the biggest problems wherein we have to run the complete regression scope for validating the emergency patch if it needs to be released. And thus, as we all know in cloud world, with each cloud release, we have new features and new functionalities that we deliver. And for with the new increase in the number of functionalities and features, we see that there is an increase in number of test cases, and hence with increasing number of test cases in the regression suite, there is also an increase in the effort that it takes to maintain and test the suite manually. And that is another challenge that we were facing earlier. Also, since EP tests are on the emergency patches cannot be pre-planned. So whenever customer faces any critical issues wherein we have to come up with a quick patch or quick fix for the issue, the critical issue that a customer faces, so we have to do a lot of manual effort and planning around it. It's not something that can be done in pre-advance. So all these problem statements led us to come up with a solution which is nothing but iScoper based emergency patch testing solution. So before getting into the solution details, I would like to explain this. What does this word iScoper stands for? Yeah. So this iScoper stands for Intelligent Scope Optimizer, which is an in-house innovation tool at SAP that helps us to point out the exact regression test automates that we need to execute or run corresponding to the development code changes that are contained within the emergency patch. So in general, iScoper tool is able to give us the test scope proposal corresponding to the code changes that are coming in from the development systems. And we have leveraged this tool to come up with our solution. So, in our solution, what we have done, we have developed a set of automated scheduling processes which generate the test scope corresponding to an emergency patch code change. And with that test scope, then we bundle it up and create a test plan on the fly. And at the end, we execute the complete test plan and share the status to the person responsible via email. Yeah. So broadly, the solution can be categorized into four major components. The first component is the schedule service. In the schedule service, the end user defines and tells our solution what is the duration for which he needs to have this automatic solution being triggered overnight automatically. Yeah. Once that is done, then we have another process which automatically uses the iScoper tool in the backend to come up with the test scope that corresponds to the code changes contained within the emergency patch. Once we have the test scope proposal, we have the third block, which automatically creates the test plan with the naming convention that is followed at our organization. And the final one is the automatic test plan execution module, which executes these test plans automatically overnight and also notifies the person responsible with the complete report of the results for the emergency patch test plans that were executed. Now, my colleague Nikhil will be taking you through the details of each module and also the demo of the solution. Over to you, Nikhil.
All right, I'm trying to share my screen. Hope it's up.
I'll stop sharing here.
All right. Thanks, Shiba. So, hope my screen is up now.
It's coming up.
All right. So, as is explained by Shiba, our solution is divided into 4 of the blocks. And now I will be explaining each of the block in more detail. The first block of our solution is schedule service. So in this particular block, hope my screen is there, right?
No, the screens are not visible. The slides are not visible. Nikhil, shall I share it from my side? Or?
Okay, let me try to reshare. All right, now the slides is up. Sorry for the inconvenience. So now I'll be taking you through the each of the block in more detail. So first of all, block is schedule service. In this block of schedule service, we have created an application which is create schedule task. In this particular application, the end user basically creates the task by providing the information. So information like the duration for which this particular solution should be active, and the information like the naming convention of the test plan or test bill with which the test cases should be created with, and what is the system in which the particular solution should execute the test cases. Other information like post execution of the test cases, where the result should be shared. So that is the email address of a particular user which will be provided. All right. So once the user has provided the information, they click on schedule task and hence the task is being get created. So now you can see that on the screen, this is the information. Basically, this is how the application for automatic AP testing solution looks like. And you can see there are a couple of information which we are expecting from user to get added into the particular application. And accordingly, we create the task. So we will be looking live and productively into the solution, and I'll be explaining into more detail once we navigate to the particular solution. All right. The second part and the second block of our solution is automatic test scope proposal. So in this particular block, what we do is basically we generate the test scope or the test cases using iScoper tool based on the code changes. So now I will be explaining into a more detail how this particular tool, which is iScoper, is able to generate the test scope proposal for us. To explain it in more detailed manner, let's assume for any development code object or the codes, for example, classes, method, or programs, for any of the development is represented by this square block. And then this blue circle represent all the test cases which we have in the regression test suite, which are covering few of the development code lines. Yeah, so that is represented by number 3, which says object touched by are available test suite. Then at given duration of time, there will be some code changes or the fixes which will be coming into the system. So these code changes at any duration of time is represented by the yellow circle which says 2. All right. Now, what is happening here is if you observe at one side, we have all the objects, all the development code, which is getting touched by our existing test cases, regression test cases. And the other hand, we are able to know which all the development code has undergo through the code changes. Now, which is the potential scope, basically, which is the scope which we should be testing. Now you can see about the intersection, which is in between of 2 and 3. Yeah, we have represented it by number 1. So now you will be agree with me that these are the potential test cases. Yeah, reason being these are the test cases which are covering which is the development code which is getting changed. And we this is how exactly in our solution we are considering optimal scope or the scope potential scope for regression test for testing the impact of the patch or the fixes which has come into the solution. Yeah, so this is giving explanation about how this particular scope proposal for our solution work. All right, let's move to the third block of our solution. Yeah, so the third block of our solution is automatic HFC test plan creation. So what we have done is we have created some background processes. So these background processes execute and triggers every day at 1:30 a.m. IST. What does it do? It basically creates the test plans for the scope which is generated in the previously explained steps. So now in the previously step which I explained, you know we have got the optimal test cases. Basically, we have got the test cases which are covering the objects or the development code lines which is being changed in given duration. So this background job, what it does is it gets all the test cases which is being proposed for the test plan creation. And now you will be remembering. And the task creation time, we have given a naming convention of test plan. So with using that test plan naming convention, it bundles up all the test cases which has been proposed by this particular solution and create the test plan. All right. So once the test plan is created or the build is created with the naming convention, we have the last block of our solution. The last block of our solution is automatic test plan execution and email notification. Till now, what we have seen, how our solution is able to derive the right scope for regression test, right scope to find the impact of the changes which has come into the system because of bug fixes or code changes. Now, at the third of the block, we also have created the test plans. Now we have bundled up all the test cases and we have created it inside the test plan. Now in the fourth block, what we do is there is a background processes. As soon as we have seen the test plan creation has happened successfully, these test plans are getting executed in the target system. Target system is the system details which we have got from user where he is interested to execute these test cases at the task creation time. Once this particular test plan execution has happened, a user whom email address we have taken at the time of task creation will be notified with the status of test plan execution. For example, in the case the test cases are failed, then user will be notified, hey, your test cases inside your test plan are failed, and which of the test cases are failed. In case it is pass, they will be informed, okay, out of all the test cases, these of the test cases are passed. So now the user know what exactly he has to do to maintain for the failed test cases. All right, so this was about the four of the blocks which we have bundled up and have created this particular solution, which is iScoper based automatic emergency pass solution. All right, so since this solution is live productively used, I will be explaining and giving you a live demo of this solution. All right, so now I'll be sharing my Chrome browser. Okay, so now I will be sharing my application with you. So let me just select the browser. Okay, okay. So now I have selected in the window my application so that you all are able to see it. Now I have clicked on sharing. Hopefully now you guys can see this application. All right, so now I can see it is coming up for you, and now it is loading. Okay, now we have in the application up and running. So now what you can see here is this is the landing page of our automatic EP scheduling solution application. As I mentioned about the first block, if you all remember, the first block for our particular solution was schedule task. So now let me click on schedule task. So as I mentioned, once I click on schedule task, a new application which is schedule task will get opened up. Then I have a couple of information here which we are expecting from end user. So I have explained about the information which I am expecting from my end user. What is the information here is the first part here is the task name. So to identify the complete task, the end user will provide the task name. So now I am giving STC QISTC as a task name. Okay, let me make it a little bit caps STC. Okay, so I have provided a task name, which is basically to identify this complete task. Okay, the second part here, what I'm expecting from end user is iScoper test plan name. So what is the iScoper test plan name is? So as a prerequisite, this is a one-time activity where all the regression test cases have to be executed with activated coverage analyzer tracer. So now you can remember we have talked about the blue circle. With this particular activity, we got all the information about the test cases and the code lines which it is touching here. So the blue circle, which was represented by 2 in the Venn diagram, will be built at this step. The second and the third, basically my information which I'm expecting is for which particular cloud release you are creating this task. So we have a couple of cloud release for SAP. Now I'll say for 2111, I am scheduling this task. Then I select which is the type of this particular cloud release. It's a odd, and then I give schedule date range. The date range for which I want this solution to be activated to derive the scope, to generate test plan, and then execute. Yeah, so I give the date range, which is from 10th of December to 12th of December. I want my solution to propose, create test plan, and execute the test cases based on the changes which has happened, which has come into the system. All right, so I have done that. Now I have to provide the information, that means the test plan name. So with which naming convention you want to create the test plan or the build. So I'll give the name the test plan underscore QI STC. So this is the name with which our test plan will get created. And then I have a couple of other information which say dev package, test sentence C pro. This information is basically from the tracking purpose. So we'll ignore this. Then we have SDC and target system. Now I am expecting from my end user to let me know, hey, which system you want to execute the proposed test cases. So there they will be maintaining the system information where exactly they want us to execute post getting the scope proposal. So once my user has specified the system information, I am also expecting, hey, let me know the email address with which you want the information in once this test plan get executed. So your test case is pass or fail, which all email ID I should be notifying. So I'm saying this email ID I should be notified in. Now what I do is I'll say create task. All right, so I say schedule task here. As soon as I click on schedule task, you would have observed the task is scheduled successfully has come. I said, okay, well enough. I'll go back into my application and now I want to see, sorry, the created task. So I have given QAI STC. I'll click on go. Here you go. So now, if you remember, we have scheduled the task from 10th to 12th of December. Every day around 1:30 IST, so before 1:30 IST, all the development code changes will be coming into the system. So 1:30 IST is cutoff time for developer to fix the bugs for that day and move it into the system. Post that, what we do is, now you can see we have split this task on 10th, 11th, and 12th of December. So now at 10 at 1:30 morning, 1:30 a.m., what happens? The background process runs. What does this background process do? It looks for all the code which has been changed from this date, which is 9th of December to 10th of December. So it will look for all the development code which has been changed in this duration. And if you remember, we have talked about iScoper tool, yeah, which derives the scope based on what is being changed in the system and identifying what is the corresponding potential test cases which are covering those changes. So our background job executes and it drives the scope or basic that relevant or the potential test cases with which it should cover the object which is getting changed. All right. Once we have got the information, hey, out of so many test cases, these are potential test case, then the background processes execute and create the test plan. So it bundle ups the potential test cases, which is being derived by iScoper and put it into this naming convention, which we say HFC test plan name. So G test plan QA STC is a name in which all the test cases will be bundled up. Suppose this HFC test plan is being created as if you remember we mentioned it will be also executed because we have taken the system from the user where we have to trigger this execution. The background process will execute and then it will notify the end user about the uh, status of that execution. So that is, how basically we are having multiple background processes. One more aspect, so I'll just select other filters here, HFC type and status. So I have created HFC type and status. Now, if you see here, the status of this schedule uh, task are scheduled. Yeah, it is coming as scheduled. Then what will happen is at the schedule date 10th of December at 1:30 a.m. IST, the processes will be triggered. The background processes will be getting triggered where it will be identifying the changes which has come into the system and propose the scope and then execute. Once this particular task in biz is processed here and we can see the test case is being proposed and test plan is being created and it is also been executed, then the status of this particular process is changed from scheduled to completed automatically. And once it is complete and then it is been executed, it will come into the execution. All right, in case there could be cases where we don't have corresponding test cases for the changes which has come into the system. Basically, the code lines which got changed into the system, we don't have any of the test cases which are covering those. Then there is no potential scope for those test cases. Then it will say there is no scope as a status. Okay, once the user has scheduled the task, then there is an option to also delete few of the tasks. Then it will come as deleted. So the status will be changed according to the processes. So based on what has happened into the system at the time of processes, it will change the status, and a user will be notified since we have taken the email address. With this, you would have seen how this particular solution is able to potentially generate the right scope for the test cases by identifying what is being changed in the system. And it is also automatically able to create the test plans for a test engineer. And later, you can see without manual intervention, these test plans get executed and information is shared. So with this lot of effort, manual effort can be getting saved from end user because this whole process post task creation is end to end automated. With this, now we have seen how this tool has potentially used to get the right scope proposal and automatically able to execute and generate the results. All right, so this was all for this demo. Maybe I'll now give it back to Shiva for discussing about the business benefit. Over to you, Shiva.
Thanks, Nikhil. I'll be just sharing my slide. Thanks, Nikhil. Thanks for the beautiful demo. And we'll be just going through the business benefits. As we all saw that now we have the complete process that is automated end to end. And we don't need to kind of run the complete regression suite. And we don't need to kind of have the same static suite. And we can just have tasks scheduled at the click of a button, and it can run on as per the dates and the durations that we have given. So this complete end-to-end scheduling solution has definitely helped us to save our test cycle time and hence the cost as well. The second business benefit that we have seen is that with this solution, we have been able to optimize our test scope because we are considering the automates or the test cases which are touching the code changes only. And that then the third benefit is that now we have a scientific method in place that helps us to get the scope proposal. We are able to target or test the right areas or the areas that have undergone change, and definitely it has helped us to improve our product quality. And last but not least, now we can better utilize our resources. So initially, the quality engineers who used to be involved right from manual testing, planning, running the test automates, and kind of putting in all their effort, all that is now saved with this one end-to-end automated process. And we are able to get this done completely automatically, and we are able to utilize those resources into some other innovative tasks. So with this we were able to plug in all the challenges that we were facing while deploying EPs and kind of trying to ensure business continuity with minimal regression efforts. I think that's all from our side, and now we can move to Q&A. Samiksha, I think there was a couple of questions which were already there. I think shall I pick them directly, Samiksha?
Sure, if you'd like to pick them, you could, or we could email them to you
Okay.
if you prefer.
Yeah, yeah. Maybe we have some time, so I can just explain a little bit. The first question was, want to know how are you finding the test scope to run on a different pull request? Yeah. So what happens when I mentioned that we are using iScoper tool? So what this tool does, this is a kind of prerequisite. We run our complete regression test suite. We call it regression test suite. It could be a build, a complete bundle of automated test scripts we are running via iScoper tool once. So what it does, this tool uses SAP Code Analyzer as the core, and it helps us to map the test automates to their development objects, which it touches while kind of traversing from one screen to another or from one functionality to another. So in turn, we have a complete mapping of each test automate to the ABAP development objects, could be function groups, classes, methods, ABAP programs that are being touched by the automation test case when it is being executed. So once we have this mapping in place at runtime, when we say that we want to see or we want to get the scope proposal for this date range, our tool connects to the target system and it reads the transport requests, and then it finds which are the development objects that have undergone change. It comes back with the list of change development objects, and it refers to the repository wherein it already has the mapping of the automation test cases to the development objects. So with this, we are able to kind of exactly find which are the test automates that we should execute corresponding to the code change that is coming in the form of a API or a development request. Yeah. So
All right, so now I can see the second question is also there. How does your system figure which are the relevant test cases for particular code change, and how long did it take to build that intelligent to a stable level? All right, so maybe I'll explain you in more detail by sharing my screen and informing you how exactly we are deriving the scope and what is the way of doing that. Okay, maybe we'll take example. Hope my slides are again up. Okay, so how does we get the right scope? Yeah, that is the question, how we identify the scope. Okay, so as I mentioned, there is a coverage analyzer tool. Yeah, and let's say for our test plan, there are regression test cases. So I denote them by TC1, TC2, TC3. Okay, so these are the test cases which is there in the regression test scope or the test plans. What we do is, as a prerequisite, we execute these test cases with a coverage analyzer, or basically a analyzer tool which tracks which code lines get touched by executing these test cases. So corresponding to these test cases, once it execute, it basically does some of the code lines in the development. So now say the test case 1 is touching the object 1, test case 2 is touching object 2, and so forth and so on. So now with this coverage analyzer, we go to know, okay, these test cases which we have are touching which object. So corresponding to each of the test case, we know which development object is getting touched. Then on the other hand, second part, which I mentioned in the yellow circle, was object getting changed. So all the changes which comes into the system comes in the form of transport request in SAP system. So we track the transport objects, and from that transport object, we identify which all of the objects or the code lines are getting changed. So now you can see the object one. You can consider object one as class, probably method, or maybe program. So this particular object got changed 5 times in one duration. For example, I say from December 1st to December 31st, let me track all the objects which are getting changed into the system because of bug fix, because of enhancement. So now this particular object is changed 5 times, object one. At one side, you can see we have test case and the mapping to which object it is touching. And on other side, you can see we have mapping of which object is changed in one duration of time. Yeah, by transport request. We map those. So now you can see object one is being changed 5 times in a given duration, and we have test case which is touching those objects. Yeah. So that's where we are proposing the test cases. Now the test case which does this object will be potential test case. The reason being it is covering the functionality which is getting changed and the impact of it. And then we are also giving a prioritization based on the frequency. For example, if one of the objects, say function, module, or class or method is changed 5 times in the given duration, then and the other is changed 2 times or 3 times, accordingly, we give the priority to these test cases. The more priority to the test case which are covering, the more frequent changes which is coming into the system. And that's where we generate the prioritized scope from iScoper as well. Hope it answers to first of the question which you asked, how basically we are deriving the scope, test for the right scope. So that is the complete mechanism what I just explained, how we're generating the right scope. And the second question is what time and how much time probably it takes. It doesn't take much time since we are considering for a short duration, and the transport request probably is not that huge. It usually basically takes somewhere from 15 to 30 minutes on an average, but it also depends on how long duration we are considering. But as of now, what we have seen, the background processes which I explained, which is automatically executing, is taking somewhere around 15 to 30 minutes only to derive the scope and then create the test plan and then execution part as well. Hope it answers your question. All right.
Thank you. Thank you so much, Nikhil and Shiba. That was great, very insightful.